This video is going to be on stationary points, which is part of the differentiation topic. Example 1, find the stationary points on the curve y equals 2x cubed minus 9x squared plus 12x plus 4 and determine their nature. So that is how this question is very often worded, and it is one to expect to see in lots of assessments and in your final exam. Your solution will have 4 steps. Step 1 will be to differentiate. Step 2 will be to set your derivative equal to 0 and then solve, most likely going to be using factorising. You're going to need to make sure you communicate a statement at that point as well. Step 3, you'll find the y coordinates by subbing into the original equation, and step 4 will be to set up a nature table which allows you to determine the nature of your stationary points. And we're going to start with our original equation, y equals 2x cubed minus 9x squared plus 12x plus 4. We're going to begin this question by taking our original equation and we're going to differentiate that. So y equals 2x cubed minus 9x squared plus 12x plus 4. When we differentiate it, it will become 6x squared minus 18x plus 12. What we then need to do for step 2 is we need to do our communication statement, which is for stationary points, they occur when dy by dx equals 0. So a statement like that I've written here would be sufficient for this part. What you're then going to do, and this is very, very important, you're then going to write your 6x squared minus 18x plus 12, and you're going to set it equal to 0 and begin factorising. So if we take 6x squared minus 18x plus 12, we can take out a common factor of 6. When we take out a common factor of 6, that leaves me with x squared minus 3x plus 2 inside the bracket. We have it equal to 0 because that's when stationary points exist, and we need to factorise it further to get our solutions for x. So what we're going to do is we're going to factorise this x squared minus 3x plus 2, and when we factorise that, we get 6 bracket x minus 2 bracket x minus 1. This allows us to get two solutions for x. The answers will be x equals 2 and x equals 1. And these are what we're going to use to get our y coordinates to finish off the coordinates of the stationary point. So for step 3, to get the y coordinates, we take our original equation, y equals 2x cubed minus 9x squared plus 12x plus 4. And we take our two values that we had in the previous step. So we take x equals 2 and we substitute that into the original equation. So we're substituting it into this equation at the top of the screen. So anytime you see x, you're going to put 2 in. So you have 2 bracket 2 cubed minus 9 bracket 2 squared plus 12 bracket 2 plus 4. When you work all that out, you end up getting 16 subtract 36 plus 24 plus 4, and that gives you 8. So that means the coordinates of the stationary point when x equals 2 will be 2, 8. You also need to do it for the other x value that you got, which was 1. So you substitute 1 into the original equation. So again, 2 bracket 1 cubed minus 9 bracket 1 squared plus 12 bracket 1 plus 4. When you work all that out, it ends up giving you a y value of 9, giving you the stationary point 1, 9. If you've got a calculator and it's in a calculator paper, you can substitute the number in and use your calculator to do it, but just be wary, this question can appear in non-calculator papers as well. Hopefully the numbers wouldn't be too bad though if it was in a non-calculator paper. So now you've got the two stationary points, we've answered most of the question. And we've differentiated, we've set it equal to 0, we've factorised, we've got our solutions for x, and then we've worked out what our y coordinates would be by substituting into the original. What we now need to do is we need to set up a nature table which will allow us to determine the nature of the stationary points. And how we do that is in the next slide. Let's have a look at the nature table then. So we have in the very first row, we have x and we have our values 1 and 2. Those are the two values that we found earlier on in the question. We already know that dy by dx is equal to 0 at x equals 1 and at x equals 2. That's why in the dy by dx section I can already write 0. Now in this one, I have 1 here with 2 arrows next to it. Now what this is going to mean is, this arrow here indicates numbers that come before 1, and this arrow here indicates numbers that come after 1. In the 2 section, this arrow here indicates numbers that come before 2, and this arrow here indicates numbers that come after 2. So what we're going to do is, we're going to work out what dy by dx equals at these particular points. How we do that is, we can effectively write down values to correspond to those arrows. Now what you want to do is, you want to make sure you're not going too far out. So if I'm looking for a number before 1, I would maybe go for 0. In this section, I'm looking for a number after 1, but the key here is not to go for a number like 3 or 4. You need to make sure that it's also between 1 and 2, because you know that 2 is one of your stationary points as well. So what you could go for here is 1.5, and then in this arrow here on the right hand side, we could maybe say 3, because that's relatively close to 2. We know that my dy by dx is equal to 6 bracket x minus 2 bracket x minus 1. And we're going to pick values 0, 1.5, 1.5 and 3. And they should allow me to work out dy by dx for those values, and that will then tell you the nature and shape of your graph. So what we do is, we take our dy by dx and we're going to substitute in for the values of 0, 1.5 and 3. So I'll start by doing 0. When x equals 0, I substitute in 0 whenever I see x in the dy by dx form that I had earlier on. So I have 6 bracket 0 minus 2, close bracket 0 minus 1. 0 take away 2 is minus 2, 0 take away 1 is minus 1. When I multiply them together, it gives me 12, and that is positive. So I can write that in my dy by dx row on my nature table, because it's a positive answer. Next one I'll do it for when x equals 3 here. So I'll do it for when x equals 3, and again 6 bracket 3 minus 2 bracket 3 minus 1. That gives you 6 bracket 1 bracket 2, which again gives you 12, which is positive. So we can put a positive in the dy by dx row of the nature table. And finally we'll do it for when x equals 1.5. When we do that, it ends up giving us a negative answer this time. We have 6 multiplied by negative 0.5 multiplied by 0.5. That ends up giving you minus 1.5, which is a negative answer. So we can put negatives in both those regions on the nature table. What we can then do is, we can then say, well, this is what the graph would look like. Because it's positive here for dy by dx, it's going to be going upwards. 0 is a stationary point, so it'll be flat there, and it's a negative here, so it's going to be going down the way. A negative here, so again it's going to be going down the way. We've got a stationary point here, so it'll be flat, and we've got a positive dy by dx here, which means it's going to be rising there. And that helps us say what the nature of the stationary points are. So to finish this question, which is really, really important, you've got to state what is the minimum turning point and what is the maximum turning point, or sometimes it might be a rising point or falling point of inflection, and we'll talk about that in the second example. Now, a couple of points to make. When you're doing these type of questions in an SQA exam, if you were to put numbers here, 0, 1.5, 1.5 and 3, you must show the working that I've got at the bottom of the screen here. So if you have a 0 at this arrow, you need to show the steps that I've got here. If you don't show them, you will lose a mark. So make sure, if you do write numbers above the arrows, that you show your working. Now, if you don't write numbers above the arrows, you don't need to show all of your work in there. You can just type it in your calculator if it's a calculator paper, get your answer and fill in your nature table. So just to summarise quickly, make sure if you do put numbers above the arrows that you show these steps at the bottom here. If you don't have numbers above the arrows, you don't need to show your work in there. You would again just type in your calculator and get your answer. But just be wary, because it can be quite tricky and it can be easy to make mistakes. So just be very wary about that. To finish off the question, we need to answer what is the nature of the stationary point. So for x equals 1, we knew that the turning point was 1, 9. We got the y coordinate to be 9. We have this shape here. That is a maximum turning point. So we'll say that the maximum turning point is at 1, 9. For x equals 2, we worked out that the y coordinate was 8. We have this shape here, according to our nature table, and that is a minimum turning point. So we will say that the minimum turning point is at 2, 8. And that is you fully answered the question. So in this question, it's quite a lot of marks. What you're doing is you're differentiating, you're writing your statement, you're then setting it equal to 0, factorising, solving for x. You then need to get the y coordinate if it wants the stationary point coordinate. You're then taking your x values that you've got, putting them into a nature table, checking before and after your x values to see what the nature of the turning points would be, and making sure you state at the very end what is the maximum and what is the minimum turning point. Let's have a look at another example then. Example 2. Find the stationary points on the curve y equals 4x cubed minus 2x to the power of 4 and determine their nature. So to begin, again, we will take our y equals 4x cubed minus 2x to the power of 4 and we will differentiate, and it will become 12x squared minus 8x cubed. We will then write in our statement. Stationary points occur when dy by dx equals 0. So we can set 12x squared minus 8x cubed equal to 0. We will then factorise. In this case, we'll take out a common factor of 4x squared. And that leaves me with 4x squared bracket 3 minus 2x bracket equals 0. We can then get our two solutions. First of all, if we have 4x squared, if 4x squared equals 0, then I know that x equals 0. Because if you divide 0 by 4, that would still remain 0. And if x squared equals 0, then x has got to be equal to 0. We can also solve the 3 minus 2x in the bracket. We can set it equal to 0 and solve using our algebra skills. So add 2x, making it 3 equals 2x. Divide by 2, giving you x equals 3 over 2. This question has got a difficult part in it because it's got a fraction, but again, if you follow the same process and don't worry too much about the fact it's a fraction, the numbers won't work out as nicely, but we'll still be following the exact same process. So now that we've got our x values, we need to get our y values. So what we do is we sub in our 0 and our 3 over 2 into the original equation. So for the y coordinate, when x equals 0, we sub 0 in to get 4 bracket 0 cubed minus 2 bracket 0 to the power of 4. That just ends up being y equals 0. So our stationary point is just 0, 0. We also need to do it for x equals 3 over 2. Now, as you can see, it's not very nice. It's quite a difficult expression. However, we still follow the same process. If you were doing this non-calculator, I'd imagine the numbers would be maybe a little bit more straightforward than this particular example. So you're subbing in 3 over 2 whenever you see x into the original equation. And that ends up eventually working through to give you 21 over 4. And again, you can just leave that as a fraction. You may have made that a decimal, that's okay, but you can leave it as a fraction. The numbers are very, very awkward there. When you're practicing this, feel free to use a calculator for the moment and see how you get on with it. Now, we've got our y coordinates now. The first one 0, 0 and the second one 3 over 2 and 21 over 4. Now what we need to do is we need to get our nature table sorted. So what we can do is we have our x equals 0 and our x equals 3 over 2. Again, we draw arrows to indicate the regions before and after that x value. Now in this example, when we put the numbers in, we had dy by dx with positive before the 0 and a positive after the 0. that's going to be something slightly different, and we'll talk about that. And for the 3 over 2, before 3 over 2 we had a positive, and after 3 over 2 we had a negative, so that one looks more like the example we had previously. But let's actually look at some of the numbers involved in this. Before 0, probably best going for -1, because that's relatively close, so I put -1 into the original equation, or the dy by dx equation, and we get 4 bracket minus 1 squared, bracket 3 minus 2 bracket minus 1. That ends up being 20 as your answer. Again, you can type that into your calculator and double check, so you get 20 for that, and that is a positive. Between 0 and 3 over 2, we could go for when x equals 1, because 1 is after 0 and it's also before 3 over 2. Remember what I said in the previous example, you want to make sure that you're not putting a number after the 0 which is also above 3 over 2. You need to make sure it's between 0 and 3 over 2. So in this example we could go for when x equals 1. We substitute 1 in, and again it works out to be a positive. Answer ends up being 4. So that means both here and here in the nature table will be positive. When we have 3 over 2, we could go one bigger, a number bigger than that, which would be 2, because that's probably the best one, because 3 over 2 is 1.5, so we go for when x equals 2. We substitute that into our dy by dx formula, 4x squared bracket 3 minus 2x, and that ends up giving me -16 as my answer. Again, feel free to use your calculator to put that value in, and that gives you a negative. And once we've got that, again, we can write this in the graph sort of section here just to show what it looks like. So you've got a positive, so that's rising. You've got the stationary point 0, that's flat, and then a positive again, so it's rising. So this is a little bit different from what we've had previously. For the 3 over 2, before 3 over 2, when we had x equals 1, we had a positive, so it was rising. Again, 0 is the stationary point, so it's flat. And then we had the number x equals 2 here, so that was negative, so that means it's going down the way. So this one's more regular and more like the ones we saw previously. Now just a reminder, when you're doing these questions, if you write the numbers above the arrows, you'll lose the marks if you don't show the working that I've got at the bottom of the screen. However, if you leave the numbers out of the table at the top and you don't put a number above the arrows, you can do that working in your calculator, and it doesn't need to be on the paper, and it doesn't need to be on your assessment paper. Okay, but it may be useful for you to do it anyway, because if you make a mistake, it might be far easier to spot if you write down the working. So I would always encourage doing what I've done at the bottom of the screen. Now what we now need to do is we now need to answer the question by saying what type of, or what is the nature of the stationary point. So for the first one, we have a rising point of inflection at 0, 0. Remember, when we had x equals 0, we found out y was also equal to 0. This is a rising point of inflection. It is rising before it reaches the stationary point, and then it rises again after. So that's why we call it a rising point of inflection, and that is at 0, 0. 3 over 2 is a bit more normal, a bit more like the ones we're used to. We have it going up, flattening off, and then it's going back down again. So that is a maximum turning point, and that is at the coordinate 3 over 2, 21 over 4. Again, it was a bit unfortunate that it was a fraction, but it's nothing you can't deal with. It may be a bit more tricky, but it's still the same process. So just a reminder to make sure you have these statements at the end of the question, because it's such an easy mark to lose, because it's so easy to forget. You've done all the hard work, just make sure at the end you round it all off with your communication statement saying rising point of inflection at 0, 0 and the maximum turning point at 3, 2, 21, 4. Hopefully you found this video useful. Have a rewatch if you need to, and let me know if there's any questions.